Hello guys, today I'm going to talk about JavaScript, this keyword and bind call apply function and also arrow function, because this is a source of confusion even to some experienced JavaScript programmers. First, let's talk about lexical scope. This should be familiar to any programmer pretty much, yeah. So you have this scope defined by this pair of curly braces. Let x equals 5, and this x equals 5 is invisible to code outside of this pair of curly braces. So it's only visible to code inside. But code inside this pair of curly braces can access anything defined outside. So if I execute this code, console log x will print 5 because this is the guy he accessed first. Even though there's another x equals 10 defined, and this console log has access to the inner scope x equals 5 covers up this x equals 10. Basically, this guy has priority. Whoever defined in the inner scope has priority over the same named variable defined in the outer scope. So this is lexical scope. Basically, inner guy has priority, and the inner guy can access outer guy, but not the other way around. So this console log x can never see this x equals 5. Okay, that's lexical scope. I think this should be something very familiar, yeah. So I won't waste too much time on it. Now let's look at one example about this keyword. If you invoke a function at the global level, a top level function, so this function, what does this point to? So this always points to an object associated with the function. So when you invoke a function, you invoke a function on that object, and that object is this. When you invoke a function at the top level, like console log f1, what does this point to? This points to the global object. So if you define global.friend equals Harry, and by the way, if you omit this global dot, just friend equals Harry, the friend is automatically global object. So this global dot is just, I wrote their extra thing there for clarity. So if you do not use the keyword let, const, or var, and you declare a variable like global friend equals Harry, and this friend is automatically a global variable, yeah. So we'll define global variable, and if you invoke function at the top level, this will point to that global variable. So function f1 return this friend. If you console log f1, it will print Harry because this function is invoked at the top level, and that top level, this points to the global object. This is just for illustrative purpose. In real coding, you will never want to create these variables because you're polluting your global environment. Global environment should be reserved for things like the date function from JavaScript, things that everybody needs to use. You shouldn't pollute the global environment with user-defined variables. Yeah. So here, if you use strict, this code will produce error message. Strict mode does not allow you to randomly create stuff under the global environment. So this is just for illustrative purpose. If a function is invoked at the top level, this keyword point to the global object. And in the browser, this is in Node.js. In browser, the global object, this is the window object. In Node.js, it's the global object. Yeah. Okay, that's the function at the top level, invoked at the global level. And this points to the global. Now let's look at another function. So for functions defined as method on an object, this keyword points to this object. So when you invoke function on an object, this keyword points to that object. This should be familiar to anybody, yeah. So I won't spend much time on this one. This should be this should be very obvious. So you define method on an object, invoke that method, and the keyword this pointed to this object. So third example, also I will just gloss over. It's very straightforward. It's almost identical to the previous example, except that the object is now created with a constructor. So you have a class, you have constructor, you have methods on that class, and this keyword will always point it to the object created. So the instance of that class. So you let p1 equals new person, and this name will point to Claire. And yeah, so the constructor and the method, this keyword will point to the object which is created by this constructor, and the object on which this function is invoked. So P1 intro, it will point, this keyword will point to P1. So almost the same as the previous example. So next example is another case. When you import a module and you invoke a function, this keyword pointed to that whatever is exported by that module. So let's look at this module. So this module has a function, return this mom, and there's a constant called mom. And when you export this function and this constant, this keyword in this function will point to these guys. So the module export is the object on which the function is invoked. So this module export a function and a variable, and the function use that variable. So this variable is accessible if it is exported. So this guy imports the module and use the module.f2. From the syntax, you know that, okay, this M1, the module, whatever is exported by the module is the object on which f2 is invoked. So you can imagine that this chunk is the object on which the function is invoked. So when you import a module, the exported stuff is an object, and the methods always invoke on this object, the exported thing. So that's the export. Okay, so we have discussed 3 scenarios, maybe 4 scenarios. The first, the top level function, that this keyword points to the global object. If a function is defined on a method, this keyword will point to the object on which the function is a method. If the function or constructor defined for a class, that this keyword will point to the instance of the class. And for a module where a function used this keyword, like this example, this keyword always points to whatever is exported by this module. Okay, so that's 4 different scenarios. Now let's look at this example, bind. So this bind function.bind with an object creates a new function with this explicitly bound to this object. So for example, function f3 returns this friend. And this friend is function, if it's invoked at the top level, it will produce error message because global object does not have a field called friend. However, if you created 2 objects, object 1 has a friend called Claire, object 2 has a friend called Josh, and if you invoke this function f3.bind with O1, so this chunk of code creates a new function where this is bound to object O1. So this will print out Claire because object 1 has a friend with the name Claire. So bind function.bind with an object will point this to this object, and it creates a new function. If you want to invoke it, you have to use a spare brackets in order to invoke it. So whoever's object is bind to, the bound object is used as the object on which the function is invoked. So basically the bind function lets you explicitly point to an object on which the function is to be invoked, and this will point to that object. So basically you just override whatever the default is. You want to explicitly set this to an object. Now the next section is super easy. It's basically the class method can also be bound to another object. So you have an animal class and you created 2 animals, and you call the animal 1's introduction function. It will produce animal 1's name. If you call animal 2's introduction function, it will print animal 2's name. But if you invoke animal 1's introduction function but explicitly bind it to animal 2, it will print out animal 2's name. So growl tiger. So the bind function will override. So even though intro is invoked on object A1, the first animal, but if you bind it to the second animal, this will point to the second animal. The first animal is discarded. Yeah. The only thing is not discarded is function definition. Yeah. but the object it binds to is now a different object. Similar to the previous example, right? So the bind will allow you to override keyword this, who this should point to. You explicitly define this for the function. Now, next example, apply and call function. So this is very similar to bind. When you use bind, you pass an object to allow this point to this object. You override, you actually override this, and you create a new function. In order to invoke this function, you have to pass the argument and invoke the function. But call and apply offers a shorthand. So if you do not want to create a new function, you just want to execute the function on another object, you can just use call, pass the object as the first argument, which is the this, and then pass the remaining argument. You will be able to invoke this call, this f4, this function, on a different object. Same for the apply, identical to call, except that the remaining arguments has to be passed in as in a tuple, so in the square brackets. So it's identical. Apply and call are almost identical, except the syntax are different. Apply and call will invoke the function, but bind itself does not invoke the function. It creates a new function, and it fixes the this keyword to point it to some object. So this guy creates a new function, and these two guys invoke the function. And the only difference between call and apply is how the remaining arguments are passed to the function. Apply use tuple with the square brackets. Okay, let's see another example. It's a function invocation. This function returns friend. Of course, in the global environment, there's no friend defined, and you have two objects. And if you invoke this function on object, so the function is defined as a method on object 1 and object 2. If you invoke this function f1, it will use object 1's name. If you invoked the same method on function on object O2, function f2, it will use object O2's name, friend names. So this basically says that a same function f, defined here, how it executes, which object this points to, depending on its invoking environment, who invokes it. If an object 1 invokes function f, it will use object 1's friend. If object 2 invokes function f, it will use object 2's friend. So that's the key point in JavaScript. The execution of the function depends on the environment in which the function is invoked. The same function may produce different results based on which object this points to. Now let's look at another example, arrow function. So arrow function is different from functions created with the function keyword. So the arrow function does not use function keyword. So this arrow function does not bind this. So this is empty. It inherits this from their parent function together with the arguments as well. So let's look at this example. We have a friend field defined on this object, and we have function 1 which returns a function that is not arrow function. It's a defined function, and this defined function will return this friend. Function 2 is identical to function 1, except instead of using the function keyword, it uses arrow function, also returns this friend. So if you f1, the invoked function f1 on object O, and then you invoked the return function. So O function f1 return another function, which you in turn invoke that function. It returns undefined because this function defined here isn't created using the function keyword, and it does not have this defined, this friend defined. It has no friend because it's not a function defined on this object. It's a function returned by a function defined on this object. So there's one extra layer in between. Now, if you look at function f2, this function is an arrow function. It means that it does not have this keyword point anywhere. It directly inherits its parent function's environment. So this friend will point to function f2's friend, which is here, because function f2 is invoked on object O. The object O has a friend. So that's what this arrow function points to. It does not have this field. It inherits the calling function's friend, this keyword. Whatever this points to for the calling function, which is f2, this will point to for this anonymous function. So anonymous function inherit its parent function's environment, like its argument or it's this keyword. So if you invoke OF2 and then invoke that function returned by f2, it will print out a clear because it returns an arrow function. That arrow function will inherit the friend from function f2. Okay, now let's look at another example. It's kind of a little bit convoluted. So if you have an object, you have a function method defined on that object and returns one arrow function, which in turn returns another arrow function. And the final return arrow function returns friend. It will print out Jared because why? Because both are arrow functions. The innermost arrow function looks for friend. Where does it look for friend? The calling function. Does the calling function has a friend field? No, it doesn't. But the calling function is also an arrow function, so it looks at function f. Does function f has a friend field? Yes, because function f is a method defined on the object. So this is the kind of chaining of arrow function. If you can't find the friend on your father, you look for the grandfather's friend. If your grandfather has a friend, you will use that friend because this is a chain of arrow functions. This is what it called the lexical scope. Yeah. So this function invoked will produce Jared. So O of function O.f returns another function, which in turn returns another function, and both return functions are arrow functions. So if it cannot find a friend, it will inherit a friend from its parent, and it can't find a friend in his parent. He looks to the grandparent, which has a friend. Okay, I hope this is not too confusing, but this is basically the key of the JavaScript arrow function, yeah, and this keyword in the call and apply and bind functions. The difficult part is this arrow function to this. So just remember the arrow function this doesn't point to anything. It inherits this from its parent function where it is defined. So if it can't find this keyword from its parent function, it looks for this keyword from the grandparent. That's basically the lexical scope of the arrow function. Okay, that's it for today.